Our next speaker is Branimir Rakic from OriginTrail. So Origin is decentralized knowledge graph, and what happens if you toss in decentralized AI on top of that. So Brana, yeah.
Thank you,
sir.
Thanks for the intro. Hey, early applause. Maybe it's too early. Don't give me such an early applause. Maybe it's not worthwhile. But anyways, thank you for sticking around. I know it's 4 p.m., so probably everybody's a bit tired. I'll try to make it interesting, and I'll also try to give enough CTAs so you can somehow pitch into this whole idea of OriginTrail. What I will be speaking about is slightly different from the previous topic, but it's quite related. We won't be talking about the usual digital assets we're used to, but rather what we call knowledge assets, and why they are important for AI. So we'll also be touching something called neuro symbolic AI, of course, agents as well. So a little bit of everything in this title. I know it might be a little bit hard to understand, so I hope that by the end of this presentation, it will be much more understandable. I'm Branimir, I'm one of the founders and CTO behind OriginTrail. Maybe I'm a bit overweight, if you can hear that sound. So I'll just move to the other part of the stage, which might be a little bit more solid. Anyways, I'll be telling you all about what this neuro-symbolic decentralized AI is about and how you can launch an agent using something called a decentralized knowledge graph. By a show of hands, has anybody ever heard or even used the decentralized knowledge graph here? Couple of hands, nice. Which means most of you haven't, so then I get to explain it fresh, which is great. All right, so I'll start with some problems, just so we set the stage so we understand what we're trying to solve for. And obviously, as AI is becoming kind of the dominant technology, or as we like to say, AI is the new UI, technically, all of these issues are very important and we need to somehow tackle them. So very quickly, because I know you probably know about pretty much all of them, hallucination, number one, everybody ran into it. It's not just an issue, it's actually a feature of neural AI. So the current AI that is dominant, ChatGPT, actually, let's do a quick exercise. When I point a finger at you, I would like you to say a word that fits into the previous sentence that the previous person said. So let's start with you. Start with a word.
Someone.
Someone said hi. Someone said hi too. Someone said hi to me.
Basically, what we've seen is an LLM in action. Everybody took the previous sequence of words and guessed the next word that makes sense. So this sentence kind of makes sense, right? So you literally did what you literally hallucinated something that nobody had in mind just like 3 seconds ago. That's a problem, but it's also a feature. So, depending on how you use it. Thanks for participating, by the way. Privacy, obviously, huge issue. You don't want to feed everything to ChatGPT. Data ownership and intellectual property, another one. I'm sure I'm speaking to the choir. We're at a crypto conference, so I think ownership is part of our ethos here, and there's no need to go deeper. Centralization, of course, as well. So obvious, clear issue. Do we want to have OpenAI or any other of the big companies be in control of all of the info and the UI and the knowledge we are consuming, essentially, and driving our systems with? That comes with bias, naturally. And even one more thing, which is called model collapse, which is very interesting. Turns out the more AI-generated data there is in the world, the more other AI trains on that. And because that is hallucinated, sometimes junk, it actually makes these AIs collapse or go worse. So those are just some of the problems or pathologies that we like to call them. And what I'll be speaking about today is some ideas and directions that we took in tackling some of these problems, obviously in an open source, decentralized way. So I'll try to skip through another 10 slides. Hopefully I have enough time for it. And hopefully that sparks a little bit of a discussion, and I'm happy to chat more about it outside as well, if we have a booth, by the way, just outside of the hall. Some people even go as far as to say that LLMs are brilliantly stupid. This is one of the leading critics of AI, of current AI, Gary Marcus, who's an AI scientist and who actually had a bunch of AI products before. And actually, there is sort of a feeling of slowing down, of that big LLMs are no longer as progressing as much as they were, so that it's not an exponential thing anymore, but rather it's kind of flattening out, which makes sense because they're running out of data, but also we're kind of getting to the point of limits of what this approach of guessing the next word really well can do. So there's a new thing that is in town. Obviously, there's agents, but there's something called neurosymbolic agents, and I'll explain that in a bit. Agent market goes burr. This is just kind of a very quick illustration where you can see what the agent market is projected to be. So a lot of growth. Everybody's betting on them. You probably even start getting sick from the word of agents. Everybody talks about agents. But they're here to stay. There will be plenty of agents all over. We'll be interacting with them, and they will be interacting with each other. So it's an exciting opportunity. But the question here is, what kind of agents do we want? How can we build some really, really good agents that ideally don't have those problems that we've seen? And there's a hint from history. History kind of looks a little bit like this. This is a picture from a paper by Google DeepMind called Welcome to the Era of Experience. And what they believe is that we are exiting the era of human data, where we would feed all this data that we produced somehow over the years, like, stuff it into that LLM and then, sort of push something out. And rather go into era of experience where agents go and experience the world and therefore generate data. Like they make a mistake, they learn from it. They store it in their memory. Some next thing they try, succeeds. Okay, they have that experience as well. And the assumption here is that we're going to go, again, ballistic once we approach the world of agents actually learning from their experience and storing it in memory. Actually, there's some hint of that bump before that you see AlphaGo and AlphaZero. That's actually what happened before LLMs broke out. So neural AI took all our attention. Back in the days, maybe some of you remember, there was like the first AI that beat, I think, Garry Kasparov, the chess master. Happened like 20 years ago or something like that. That AI was actually symbolic AI. And what is symbolic AI is it just kind of computes what are the options. Chess turns out to be a simple game that has a finite number of options. So that AI, I believe it was IBM's AI, was basically computing all of the options. But like it wasn't hallucinating. It was just like creating genuine, plausible paths in this game. And whenever you were playing against it, you were just filtering out the remaining paths for it, and of course it will win. But turns out that if you take the game called Go, it's actually such a weird game that it has so many possible states that there's more states than the atoms in the universe, something like that. So it's not possible to pre-compute all the states because then you don't have an infinite hard drive, right? So they had to do something more clever. They had to do some predictions. So it's kind of a mix, and it's an early neurosymbolic AI. It didn't just compute all the states, but it did compute the states close to where you were, and then it would predict, just like you guys predicted the word, what is sort of the most common possible next step. So it's a combination of this neural guessing, hallucination, and actually computing something which is plausible, something that we can see a few steps ahead. And the assumption is if we take that approach and we apply it to, for example, physics or math, this alpha proof that you see with the red, that's actually recently won, I think, third place. It's the International Physics Olympics. So it's still not better than the best human, but it's actually proving math. So it's not hallucinating. It's taking some system and it understands the system and it actually goes and proves a theorem, which is a huge thing. That's something that LLMs cannot really do. They just guess something. So this is the thesis here is when we have agents that can do both symbolic learning, doing something with actual logic, and with this creative guessing, we're going to have all the pieces we need for some really awesome AI. So the only thing that remains is we make it decentralized and trusted, right? So I'll talk about how we do that today. There's three main components of agents. Number one is systems. They either interact with other agents or with other systems, so that's their domain of agency. Then there's the AI models. They do RAG, they do chain of thought, all kinds of things. They're the sort of natural language interface. But what I like to focus most today is memory. Memory is the kind of the key point. That's where the agents record these experiences and basically all the outcomes, mistakes or not mistakes. So when they need next time to make some decision, like in chess or somewhere, they can look up that memory. They don't need to guess if they already saw that situation. And So it turns out that if we have some really, really powerful memory, we can make some really powerful neuro-symbolic agents. But if we feed that memory with junk, it's another garbage in, garbage out system, so it won't be reliable. So we want a way to tame that junk. So the kind of agents we're looking for are the ones that reasonable, that have some reliable reasoning, they don't hallucinate, they have information provenance, so that means we know if some junk is coming here or not. We want to know who basically fed it some information. Where did it learn something? Was it the agent himself, or was it some random guy from the internet claiming the earth is flat? We also want fair value exchange and incentives, obviously. That's why we're here. These agents naturally will be connected. We live in a connected world, so there will be multiple data sources. We want to have a respect for data ownership. So we want both us as humans, but also as agents to have their own data that they own, and ultimately privacy preserving. I think this also goes without saying for this crowd, there's no need to explain that. So ultimately, the vision is of something called trusted collective neurosymbolic AI, where we combine this creativity and these facts. So the facts basically having some deterministic system that can do logical reasoning, that can do rule-based inference, and that has trusted execution. Well, I'm pretty sure when I say trusted execution, you guys already kind of infer that I'm going in the direction of blockchain, obviously, and not just blockchain, but also in these elements above actually fit to something called knowledge graphs. So this domain on this left side of the brain, the rational one, is actually in the vision that we present what we're building as the decentralized knowledge graph. On the right side, we have creativity. So basically the LLMs, they are great for some things, statistical predictions, natural language, things like that. Questionable execution, but you're not necessarily going to give it all the power you want. You want to pair it up with a left brain, right? So left brain and right brain, when they work together, you get something very powerful. What are knowledge graphs? If you haven't had a chance to touch them, this is a screenshot of one of them from the OriginTrail decentralized knowledge graph. And basically what they present is a semantically rich data representation, something that AI loves. It basically, you give it very, very concrete data, something like a typed object in like, say, an object-oriented programming paradigm. And it's able to actually do logical reasoning. It's able to do inference, even without like an LM. So because if there's a rule encoded, let's say a rule says DNA is only comprised on AT and GC molecules, right? And they only combine like that. So then you can use that rule to basically, understand that something is wrong, for example, that somebody connected something that shouldn't be, and other things. It has flexible data model, so that means you have things, not strings, so these things can be connected as in this subject, predicate, object pattern, and it's a very mature technology. That's one of the key things. It's been developed under the auspices of W3C, so there's plenty of standards used by Google, Amazon, Netflix, Uber, NASA, you name it, everybody. And they're using them as AI for a very long time, so way before ChatGPT. And they've basically perfected a way how to create value from data, but in silos. So what we try to do with the decentralized knowledge graph is bring that in an open source, decentralized way to the world, and that anybody can actually take that power and do it for themselves. A little bit just more about knowledge graphs. So think of it as two entities. You connect them with a relation, and with this you can model the entire world. You can model a relationship between people, between things, between agents, whatever you want. For example, you can have Toy Story, who has a director, his name is John, I believe. I don't see it from here. And then that could be another thing, and then you have some literal, for example. And then you can make as many connections as you want. You have to change your data model because you're building an app and you figured out you need a new feature, or your agent learns about a new concept, just adds a new connection, description of that thing, and it can go wild. So essentially, we get the decentralized knowledge graph, which is this middle layer of the memory, and it's a decentralized network of nodes that share public or private knowledge assets. We have the blockchains that are underpinning this knowledge, which provide data provenance, identity, ownership. Actually, no data in this paradigm sits on the blockchain. We don't want to bloat the chain. The chain doesn't have the query engine that we need. It has some query engine, but it's not as powerful as knowledge graphs require. And then on top of that, you can build agents or any type of AI with protocols like MCP and so forth that leverage the two layers below, so that each of these pieces of information has structure and it has an own known publisher. What does a publisher do? A publisher creates knowledge assets. Each record is a knowledge asset, or a memory for your agent. You can consider it as a knowledge asset. What is a knowledge asset? Well, it's an NFT of knowledge, technically. It contains an NFT, cryptographic proofs of the state of that knowledge, pardon me, has some graph data and some vector data. You can combine it. You can use one or the other. But ultimately, the point here would be that you have an ability to create a record. The record has an attached NFT to it, and then whoever is the owner of the NFT gets to manage that asset. So I can update it. Kind of like a Git branch. I can do more commits, but only if I'm allowed. And then this piece of knowledge fits with other knowledge in the graph. So it's considered as one entity, and I can connect it with other entities. This can be knowledge about any object in the world, or any NFT, or anything, or any agent, or it can be a single memory. And I think I have a slide that shows that memory later. I know I'm close to the end of time, so I'll try to speed it up a bit. Ultimately, what happens is you have this network of nodes, which, again, the decentralized knowledge graph is not a blockchain. So there's two groups of nodes, the core nodes and edge nodes. Edge nodes designed to run on edge devices, phones, laptops, and so forth, so you can keep your data private on your device. So you don't have to publish it to the decentralized knowledge graph and therefore make it not private. But if you do want to publish something that you want to be public, you will publish it, and that will be hosted by these core nodes. And these core nodes are basically running with high uptime. They're incentivized to do so, and they're incentivized by those fees that you spend to publish using the track token, the native token of the decentralized knowledge graph. So technically, what you can do then is you can run a decentralized agent on your phone that has certain knowledge on its own, and it can also interact with knowledge of others. And therefore, they can generate memories together through interacting with the world, sorting some of them to remain private, some of them to remain public. And those memories, as I spoke previously in the workshop, are actually something that they can cross-share in the same graph. So for example, we had a situation where one agent on Twitter, we told it my favorite food is pizza, and then you can go and ask another agent, hey, I told this other agent my favorite food is pizza, what is my favorite food? Can you go find it? And actually it did. It went and it said, yeah, it's pizza. So technically what we're creating is a collective decentralized trusted memory where each agent has its own records and is able to decide how to share them with others, while these records are used for RAG, as it says here. So decentralized RAG. So every time you read a record, or every time an agent makes a decision based on some memory, it can tell you exactly which memory it used, who was the publisher of that memory, at what time, and what it contains. So it's not like hallucination, but it's actually a piece of knowledge that was packaged in such a way that it can be used and reused. And the network has been growing quite steadily. This is just a screenshot from, I think, this morning of the staking UI. So this is the number of knowledge assets on the right, the steep hockey. And a little less steep hockey is the total fees in track tokens. So it's growing quite rapidly. So we're reaching close to 1 billion knowledge assets. By the way, this is used by plenty of enterprises as well. So OriginTrail actually started 2013 without any blockchain or whatsoever. And we started building solutions with knowledge graphs, and very quickly realized that if we want to build something which tracks bigger systems, bigger supply chains, which is where we started, it couldn't do so without decentralization. Everybody wants to keep their own data. Nobody wants to, put data in one place and, we call that one place whatever. So actually, we married knowledge graphs with blockchain ever since the first idea was born in 2016. 2018, we launched the version 1, the mainnet of OriginTrail, so it's been around for quite some time. Launched on Ethereum back then, expanded to Polygon, Gnosis, Base, Polkadot, meanwhile. And from 2022, we've actually started doing these integrations with a bunch of enterprises, including the Swiss Railways, major US retailers like Walmart, Target, Home Depot, a bunch of other companies. And just recently, we launched another venture called Humanitech together with some of the biggest names in the adult industry. You can see a video about that outside. Anyways, we cannot build this whole thing alone. It's quite a big thing. It's very ambitious. So there's a QR code, which is a call for papers. If you guys are building or thinking or researching in any of these areas, decentralized AI, knowledge graphs, neuro-symbolic AI, we'd love to chat, and we'd love to see what kind of research you can contribute to the ecosystem. There's also some pool of rewards for the best papers. So if you scan this, we'll tell you a bit more about it. It's not open yet, so you're kind of very early. You can consider this a bit of alpha. And yeah, this is a joint thing. This is an ecosystem thing. So it's definitely something that we'd love to see more folks join and join this vision of collective neuro-symbolic AI. There's one more thing you can do. At this conference, we're also participating in a hackathon, so you can build your first neuro-symbolic agent with memory stored on the OriginTrail decentralized knowledge graph. So if you scan this, it's your classic hackathon page. And you could build something like this. For example, this is a screenshot of the edge node of OriginTrail, which showcases one small set of knowledge assets connected, and including its owners and publishers and so forth. So this is actually the equivalent of a blockchain explorer in the OriginTrail world. You explore graphs. So yeah, you can take out agents, edge nodes, and even just the classic SDKs and build something exciting. As long as it has to do something with neuro-symbolic AI, we're happy to see your submissions. And if you're building, we're just outside, so do come to our booth. We're happy to help you out. And with that, I'm just gonna do one more CTA. If you want to join the community or submit your paper or build agents, this is the best place to start. This is the official docs. And yeah, happy to have had a chance to present this idea in front of you folks. I hope it was interesting, and looking forward to seeing you the rest of the conference. Thank you. I'm not sure if we have any time for questions, or if we haven't have questions. We do, right? All right.
I'm going to try to not hog the microphone. I have a lot of questions. So one that struck me is, so these graphs are basically structured data that is linked together with edges. And are all the graphs, are there like separate graphs? Or is there like one big graph where everything is actually connected?
That's a great question. So you can launch your own, we call it paranet graph. So basically consider it as a boundary. And then you decide what kind of boundary should it be. So for example, we can create 10 paranets today that are all public. Let's say one is about sports, the other one is about cars, whatever. And we can make them public so anybody can publish knowledge into them, which means also somebody can like publish junk inside, which also means that you can make it permissioned. So you can say, okay, only these people who, let's say, have this NFT or who have this or that thing, they would be able to participate and add knowledge to this paranet. There's also a way to make private paranets, so among multiple nodes. So for example, let's say you and me, we want to create 2 agents that work together, and we can have our own paranet that only our nodes get to share and synchronize these knowledge assets in between each other. Yet still the chain is used, so all of the fingerprints and the NFTs, they stay there, so we can maintain this trust between the two of us, the two of our agents. So there's a lot of flexibility. This feature is called paranets. I didn't get to speak about it much, but happy to show more if you want.
Was there someone else, or can I ask another follow-up question?
I'm good, if you guys are good.
Just a quick one is, so essentially this is a peer-to-peer network.
Yes.
Where anyone can join and be either a core node and with bigger hardware, or edge node by just like synchronizing some part of the state and serving it to other peers in the network?
Yes, very good point. So if anybody can run a node, and to run a core node, you basically need some solid server, but it's not like a Bitcoin mining rig. It doesn't like eat up all because there's no mining involved. But it does require uptime, and it does require a certain amount of stake, as with many of the other protocols. So stake tokens on the node, and basically from that moment on, your node is part of this core network, which means it shares the fees with other nodes that are accumulated from publishers. By the way, there's no inflation. The token has been pre-minted 2018. There's like everything is circulating. There's no incentives of that sort. Like where does the yield come from? It comes from publishing, from usage, from that spike you've seen, and actually these nodes compete on uptime. So the better the uptime, the more rewards you'll get. The more stake you attract, the more rewards. The lower your fees, because that helps adoption, the better the rewards. So, and finally, the more knowledge you publish, the better the rewards. So there's a combination of those 4 factors, which are all positive for the ecosystem that evolved over the years, that would help your node. So you can, for example, you don't even need to create your knowledge. You can just open up your node as an RPC to the rest of the world. So it's not like in Fura, but it's like your node, and you take, let's say, 10% of the world publishes through you. You get a bunch of benefits from that because you helped the ecosystem grow. Edge nodes, they don't get any rewards because they're not hosting the entire network, but they can plug in, they can host your private data. The idea is that they're a bit more like your app on the phone, while the core node is more like a server. But it's all open source, and pretty much anybody can participate. So there's no central government that would say whatever. And you can actually integrate different chains. So there's currently, like I said, 3 chains supported, but we are looking to support many more chains so that you can create these knowledge assets on, like, for example, Solana or something like that. No, not Solana, not Solana. I'm just kidding. Any chain. We're not religious in that sense. We think that if people want to build with this and it brings value to them, whatever chain they want, that's fine with us. Thanks for the question. There's one more over there.
Yeah, hello, my name is Valentina. Thanks for an amazing presentation. Probably my question related to the previous questions. As I understood, we have this knowledge graph containing like proved facts, and then we have agent-user communication history. Is there any, let's say, protocol for syncing this data and maybe like fact-checking of the information that user inputs? And because probably we want to use this information provided by user just like somehow automatically or semi-automatically extend our knowledge graph.
That's a very good point. I spoke about it briefly at the workshop like 2 hours ago. So I'll try to summarize 2 points. One is there is no embedded algorithm that is going to verify if something is true or not, because something like that doesn't exist in the most general sense, and I'm not sure if it will ever exist. So the protocol is very neutral. It lets anybody publish anything, even garbage. So like I could come and feed your agent garbage. It's up to your agent to then decide like, what would I do with this? You know, and the best way for it to decide is to see how it fits its existing world model, which the world model is ideally a graph in this sense, but also can be some form of system that you built on top that, let's say, either filters by identity or filters by some form of reputation, and that is something that needs to be built on top. So it's not part of the DKG per se, but it's something that we, for example, have experimented a lot with in DeSci, for example. There's quite a lot of interest about OriginTrail in DeSci space, and there's a project that has been basically creating knowledge graphs from scientific papers. So what they did is they would let everybody publish PDFs, literally, convert PDFs to knowledge graphs, but then they would have a system that would go on their own, check, like, is this a real paper? Where is it published? You know, and it would go up a couple of places on the web and basically publish its own knowledge asset saying, hey, I've checked it, you know, and so now the question is, you know, is this good enough for your case? For them, it was, you know. So it's, but yeah, it's ultimately you need to build, let's say, your, let's say, truth algorithm for your domain of knowledge, and it can be done. It's a very interesting topic to look into, though. Like reputation scoring, yes, yes. When you think about it, social media does that a lot, you know. But that it's questionable what reputation is. Like, why does Elon Musk keep popping up in my Twitter feed? I don't even follow him. You know, so he has a huge score, and essentially they have a graph under the hood. It's a social graph, and they have points to each one of those accounts. Think about you building your type of algorithm that is under your control, and you know, then you get to alter it over the way, and then you assign reputation to a source. Therefore, trust the source. The whole the tagline of OriginTrail. But yeah, happy to chat more about it if you want outside. I see there was one more, right?
Hello, my name is Dennis. Could you briefly run us over the tokenomics?
Sorry, what?
Tokenomics.
The tokenomics.
Yeah.
Okay, yeah. So again, whenever somebody adds knowledge to the graph, they would pay a certain amount of fees in the track token. Track is this limited supply 500 million token that was pre-minted 2018, actually launched with an ICO. And this was, those were all the tokens that ever will exist. The assumption is the more people use, the better thing we build, the more people will use it, the more tokens will get locked, the less tokens in supply, then you can kind of think of what comes next. But that's kind of the key assumption from the beginning. And then what does the token then do? So when I publish some knowledge to the DKG, the tokens get locked into contracts, and then these core nodes, they compete to provide the service for that. The service is not just storing, it's also serving, so querying. And essentially, you can, as a node runner, get pieces of that big reward pool that gets accumulated over what we call epochs, which is 1 month is around 1 epoch, and compete for those rewards. How do you compete? 4 different things, like I mentioned. Uptime. If your node has higher uptime, it's going to be proving that over the course of the period through something we call random sampling proof system, which we're just releasing right now, actually. And it's proving that over a period of time. So the more proofs it submits to the chain, the higher the uptime. The proofs are actually Merkle proofs of the graph. So they prove that they actually host the knowledge, the right knowledge. And then on top of that, 3 factors. So the amount of stake you attracted to your node. Delegators would delegate stake because they see your node is good. The amount of publishing that your node is responsible for, like I mentioned previously. So somebody can, like I can run a node and open up my node as an RPC into the network so that somebody can publish through my node. That's a positive behavior for the network, and therefore it's incentivized. And then finally, the, let's say, ask price, the vote of the node towards the network. So if my node is asking for less, if it's less greedy, let's say, that's positive for the network as well. So that means over time the fees go down and the adoption is more lubricated, if you will. So those are the four elements of tokenomics. There's a whole RFC on that. We have a very comprehensive set of RFCs that are always vetted with the community. So if you guys are interested in learning more details, I can share that as well. But I hear the on the side, so I think it's my time to hop off this stage, and thank you again. Do I leave this for you?